This conference will now be recorded.
Can you hear me, guys?
Yeah, Shiva.
So today we are going to speak about containers, and as a part of containers, we will be learning Docker is for creating containers, Kubernetes for managing containers, Kubernetes for managing containers. So before that, let us understand. So there are different ways to run a web application. So what are the different ways of running a web application? Now for that, let us open a diagram. Now just have a look at this diagram. In the first approach, like generation 1, okay? Suppose I want to run one web application. Okay, so just imagine that a web application is you are running in your UAT environment, pre-prod or QA, whatever it may be. So to perform that, you have bought one highly configured system with i7 processor, 5 TB storage, 64 GB memory. Okay, i7 processor, 5 TB storage, 64 GB RAM.
Okay.
But after purchasing of the system, okay, so your application is not consuming. Okay, this much memory. Just imagine your application is consuming only 1 TB of storage, 16 GB of memory. 16 GB of memory. Okay, this is completely wastage of resources, right? So this is a physical system where my system resources are wasted. So when all my system resources are not used efficiently, can I share these resources to somebody else? No, it is not possible, because whatever resources I have purchased, okay, completely they are dedicated to one physical server. In this case, all my system resources are wasted. So to overcome this problem, okay, what I will do, so in the next approach, what we can do, same virtual machine is there, same physical or virtual machine is there, okay, with same configuration, like i7 processor, 5 TB storage, 64 GB memory. Okay, this can be either physical server or Windows system, Windows operating system, or Linux operating system, whatever it may be. But you are using how much memory here? Okay, the total memory you have purchased is 64 GB. But out of 64, just you are using only 16. How much memory is left over here? 48 GB. 48 GB. Okay, here also system resources are wasted. So so in the second approach, what I can do, okay, I want to efficiently use all these resources. To efficiently use all these resources, on the top of this physical server, I can have a hypervisor software. Okay, hypervisors like Oracle VirtualBox, VMware, Hyper-V. Yeah, these are the hypervisor softwares. So using hypervisor software, okay, we are able to create as many virtual machines as we want. Okay, on the top of this physical server, okay, I can have, okay, as many as virtual machines as I want. So I can create a virtual machine 1, virtual machine 2, virtual machine 3. Virtual machine 1, I can create with 4 GB of RAM, VM2 4 GB, VM3 4 GB. So each and every virtual machine is a physical server. It is just like a physical server. So each and every virtual machine will have its own memory, its own processor, its own hardware. Okay, so all we need to know is, okay, so every virtual machine is going to take all resources from this physical server only. That means in the second approach, what is happening here? My system resources can be used efficiently. So in the first approach, what happened? Even though my system resources are wasted, I cannot reuse them. But in the second approach, since I have 48 GB unused memory and unused processing
Storage.
capability, unused memory, I can efficiently reuse them across my virtual machines. So each and every virtual machine will be acting as a individual server like this. Now this is the second approach. So in the second approach, we can have as many virtual machines as we want. Okay, but what is happening in the second approach? Second approach is also having some problems, some limitations. What are the problems? Now just have a look of this example. You suppose you have a virtual machine created in your local or a cloud platform here like this. So in this virtual machine, suppose you are running one e-commerce application. So all we know that e-commerce application is a combination of many microservices like login services, their net banking, authentication, delivery, shipping, database module, cache module, okay, and login module, logout module, sales module, many services are there. Now everyone knows that in USA, okay, this is just like Amazon shopping website or Flipkart. Okay, so suppose this is application is running in one of the Amazon shopping website or Flipkart, and all we know that in the month of November or December, these people will provide some offers, right? Like on the occasion of Thanksgiving Day, okay, Christmas, they are going to have some offers. Okay, just imagine offer is like uh, i7 processor for $100. It is excellent offer, right? Nobody is going to lose that offer. So as a part of that offer, so many members across the world, okay, like these are the customers, they are trying to grab this offer. But all of a sudden, what is happening? As number of users are increasing, okay, the load on the processor is increased. So one single system is not enough. One single system is not enough to handle more number of users. Okay, so for that we need to add to handle more number of users. So suppose every machine can handle 200 user requests. Sorry, 500 users. Okay. So across the world, not only 500 users are connected, right? Totally more than 5,000 or 2,000 users are there across the world. So to respond to 2,000 users, one single virtual machine is not enough. One single virtual machine is not enough. Okay, we need to have, okay, more than one virtual machine. In our case, just I launched 4 virtual machines. 4 virtual machine means, so if each virtual machine can handle 500 users, 100 users, and there are 4 virtual machines, 4 into 5, it can handle 200 users. So 2,000 users requests. Now, there is a challenge over here. What is that challenge? What is the drawback means? Every time when a new VM is replicated, all my services like login, banking, authentication, delivery, all the services are replicated in the newly created virtual machine. But my intention is I don't want to run all the resource, all the services, because in the festival season, all uh, modules are not busy. All modules like login, net banking, authentication, delivery, DB module. Okay, some hundreds of modules are there. Every module is not busy. Only few modules like login module, net banking modules are busy. And assume that for net banking module, it takes only just it is an application, right? Small application. We need only 10 MB of storage. Here also we need 10 MB of storage. Okay. So just for replicating 10 MB, 10 MB, so we are using complete virtual machine, right? So complete virtual machine means, as we know that every virtual machine is going to take a complete operating system. So complete operating system means that operating system might take like this amount of storage, 1000 MB. But here this is my OS size. Every application, every virtual machine takes this much amount of memory for operating system. For small modules, it is taking only 10 MB, 10 MB. Now you can tell me, just for the sake of 20 MB, 20 MB of occupancy, how much storage we are wasting, guys? 1000 MB. Because every virtual machine is going to take 1000 MB of storage. So this is not a good idea, right? Application size is only 20 MB, but my OS size is 1000 MB. For the sake of 20 MB, is it a good option to create a virtual machine with a complete operating system? Because operating system takes a large amount of space, because it is complete operating system. Okay, so just for the sake of 20 MB, it is not better to have a virtual machine with 1000 MB of storage. This is a great drawback, biggest drawback of virtual machines. How you can overcome this drawback? To overcome this drawback, okay, so it would be better to create, okay, a virtual machine. Okay, here I don't say virtual machine here. It is better to create one lightweight virtual machine. One lightweight virtual machine. Okay, with minimal, with lightweight operating system, with minimal features of operating system. Here it is occupying 1000 MB. I don't want to have this complete operating system. I don't want to have this complete operating system. This is complete operating system. Now just for the sake of this login and net banking module, okay, if I can have a lightweight virtual machine with minimal features of operating system, it is excellent choice. Is it clear, guys? Is my point clear?
Yeah, Shiva. So
Now, So rather than creating a complete virtual machine, okay, it would be better when we have a lightweight operating system which is large enough to run my application. Okay, so such concepts leads to containers. So how we can define container? And to create container, we need image. Like to create a virtual machine, we need OS image, right? In the similar way, to create a container, we need image. Okay, and you may or may not believe you can create a container. Okay, even with 5 MB of storage, 5 MB. Even we don't have a small MP4 file with 5 MB, but you can create a container with 5 MB. See how much less capacity it is, how much how wonder it is. Okay, now every container will be created, okay, by the concept, by images. To create containers we need image, but who are going to provide images? There are so many places. Okay, so one such popular organization is Docker Inc. Actually the concept of container is not new in IT sector. Okay, the concept of container is actually old, but Docker, the company Docker, has made it very simple. Okay, before Docker also, before Docker introduced containers also, there was a concept called container. But in those days, creating a container is very much difficult. So Docker company made it very simple. Okay, so like if I say something like containers, now just have a look here, containers, images. So these are just like generic containers, right? Containers. Just have a look here. Here the purpose of containers is what? To transport the goods from one place to other place. Okay, to in our case, container will carry our application. Okay, so it can be a .NET application, it can be a Java application, it can be a Python application, it can be a Node.js application. Okay, whatever application it may be, container is responsible for running your application. But to create container, definitely we need image. So here there is a famous image store like hub.docker.com. Here you have to create one account, guys, here. So if you want to create one account, click on register and type your username and email password. A free account is created within minutes. So once your account is created, you can log in into this account. So this is my account credentials. Here this is my Docker Hub's homepage. In your case, okay, these images will not be seen. These images are created by me. Okay, this page is empty. Now suppose I want to have one image like BusyBox. BusyBox is one kind of Linux. Okay, now if you want to create a container, first of all you have to download the image. So to download the image, they have given a command called docker pull BusyBox. Docker pull BusyBox. Okay, now these are the tags. If you click on tags, tags are just like versions. This is the latest tag. This is 1.36 tag. So here you have to specify the image name colon tag name. So if you don't specify any tag name, by default it will treat that latest tag. Latest image will be downloaded. These are all tags. Here, if you want to know more information about BusyBox, you can have a look. Here, these are various commands, and you can see what is actually BusyBox is. Suppose I want to create, okay, a Jenkins container. Click on Jenkins. Here, these are all tags. Tags and versions, and you can know exactly what is Jenkins. Now, how container is defined? Okay, here you can compare a Docker image with a static entity, and container with a active process. Now just have a look here. On the desktop, I have so many images on my desktop. You are seeing right here. Google Chrome image, Microsoft Edge, VLC media player, go to Docker desktop. These are all images. Suppose I click on this Google Chrome. This is image. And when I click on this, what happens? Immediately process is created. This is just like container. So like this process is having some properties. Suppose I want to know all the properties of a Google Chrome, because it is running in the background. Okay, because every process here uh, consumes some system resources, right? Like memory, hard disk space, okay, and IO. So how to know that? When you press Control Alt Del, Task Manager is displayed here. Alt Del. Okay, go to Task Manager, and you seeing right? This is all process that are running in the background. Now this Google Chrome is occupying, is consuming this much CPU, this much memory, this much disk space, this much network. Like this, when you create a container, exactly your container can be treated as a process. Okay, treated as a process. Actually, the concept of process is not new. Okay, that was there in the industry long back, even from long back. But Docker has made it very simple. How? Every container is created, okay, by a concept in Linux called namespace and C groups. So what is namespace actually? Namespace actually it is a concept from Linux. Using namespaces, okay, isolations are created. Isolations are created. Just a minute, guys. Okay, using namespaces, isolations are created. So here each isolation is considered as a container. Okay. So every container will get a process tree, CPU and memory, network will get own its own process tree, CPU and memory, network, okay, storage, everything is completely isolated. Okay, so how many containers you create, that depends on your hard disk capacity, system capacity. Okay, where you are running Docker, So every container can be considered as an isolated area. So the such isolations are created by using a concept called namespace and C groups. Okay, so here, so each isolation means here every container is nothing but what? Isolated area. Isolation will get its own process tree, CPU and memory, network, storage, and the application runs inside a container will get, okay, its own, and the application runs inside a container will get its own memory and its own storage and its own CPU and process. Okay, so how you can define a container here? Container is nothing but it is a isolated area. Okay, so each isolation will get its own process tree, its own memory, its own CPU, its own network, its own storage. And why for these C groups here? C groups are nothing but control groups. C groups are nothing but control groups. So control groups, C groups are used to, okay, specify resources, okay, to a container. That means while creating container, how much RAM a container should take, how much storage should a container take, how many CPUs a container should take. So that kind of resource limit, so you can specify with C groups. Okay, so internally they are going to be used. As a DevOps engineer, your responsibility is, okay, to create a container. Not only create container, okay, what are the rules, what are the roles and responsibilities of a DevOps engineer, that we are going to discuss soon. Okay, now now just understand this website. There is a excellent website here, and just have a look here. This is very beautiful website. This is completely has given the idea of for namespaces and C groups. Refer here. Just have a look here. This person has written this article, and see, I told you, right, every container will have its own process tree. Now just you can imagine, this is a parent process ID. Parent process ID means it is your virtual machine. On the top of virtual machine, we will be creating containers, right? So this is child namespace. That means child is nothing but it is containers namespace. It is containers namespace. Okay, like this, every isolation, every container will have its own process tree. And if you still scroll down, that means you're using process namespace. Using process namespace, a separate process ID will be created for container. A separate process tree will be created for a container. Every container will have its own process tree. So I think everyone might be knowing this is process number one. Process number one is what? Root process. Okay. So under process one, we have 2 and 3 child process. For 2, we have 4. Under 3, we have 5, 6, 7 also. This is under 6, we have this container 1, 8, 9, 2, 10, 3. This is completely isolated process tree for your container. And if you scroll a little bit down, this is a program. Forget about program. We don't write any program here. Internally, this program will be created. And this is your net namespace. So I told you, right? Every processor, every container, every isolated area will have its own networking. Okay, this is your virtual machine main system network. Okay, how this network namespace is created? By using a concept called network namespace. By using a concept called network namespace. Using network namespace, okay, a separate namespace, a separate net namespace is created. This is child net. This is, you can imagine, this is container 1. For container 1, this is a network card, and for container 2, this is a separate network card. And this is mount namespace. So in the mount namespace, storage will be created. And just have a look here. This is your main namespace, means it can be your virtual machine. So here, this is a hard disk of your virtual machine, and these are the hard disks. So these are the child mount namespaces. You can imagine, this is container 1 namespace, and this is container 2's mount namespace. And for container 1, this is one virtual hard disk. For container 2, this is one separate hard disk. Okay, this is all about containers. Guys, is the concept clear? Why containers are best when compared to virtual machines? Okay, how containers are created? What is isolated area? And what container will have? How containers are created? Did you get some idea about containers? And did you get the advantages of containers over virtual machines?
Yes, Shiva.
Yes, Shiva.
Here the major difference between containers and virtual machine. In virtual machine, okay, your operating system takes lot amount of space, whereas in containers, a minimal operating system is created. Minimal means minimal. It is a lightweight operating system. In containers, we don't have any control over the operating system, but whereas in virtual machine, we can have control. But here operating system is not my job, not my main issue. Our major focus is to focus on the application, not on the operating system. That means for the scenarios where application is most important, not operating system, then we can go for containers. Now, if you are working in an organization as a DevOps engineer, majorly you will be working on 6 to 7 projects. That depends on your experience level. 6 to 7 projects will be working, and 50% of the projects will run on VMs. For this, you have to know what Terraform, Ansible, and rest of the projects will run on containers. For this, you should have to know Docker, Kubernetes. Now, one more important thing you have to know. Here, the moment you install Docker in your virtual machine or physical laptop, okay, what happens here? There are three components are created. There are three components are created. What are the three components that are created? The three components are Docker client, Docker daemon, okay, local system. That means local registry, Docker registry. Okay, so three components that are that gets created: Docker client, Docker daemon, Docker registry. And Docker client is a system from where you are running Docker commands for creating containers, for starting containers, for stopping containers. Okay, for every requirement you are using, we are going to use Docker client. Suppose from Docker client, I want to create a container. Generally, to create a container, we are going to use a command called docker container run --name c1, something like this. So immediately, whatever command you are giving from Docker client will be submitted to Docker client, Docker daemon, sorry. Docker daemon is a background process. Docker daemon is going to verify whether the requested image, here the requested image is what BusyBox, whether this requested image is found in the local machine or local registry or not. So if it is there in the local machine, immediately it is going to collect the image from the local system. Immediately it is going to be handed over to Docker client. So if it is not there, if it is not there in the local machine, okay, so it will connect to, okay, these registries. These are images stores. This can be either hub.docker.com or AWS ECR, Azure ACR. Okay, in cloud also we have so many places where we can have images. Okay, from there it is going to bring the image. It is going to hand over the image to the requested client. This is the flow between three components that is going to happen when you are working with Docker. Okay, now our next step is to install Docker on Linux Ubuntu VM. So you can install Docker on Linux virtual machine or Windows virtual machine also. But Windows virtual machines, Windows containers are not that much popular. Okay, our 100% coverage, course coverage will be on Linux only. Okay, at last, if possible, I will show how to create Windows containers also. But that is a secondary option, because most of the times we are going to use only Linux containers, not Windows containers. Now to create containers, let us log in into AWS. Click on instances. Here I am giving a name called Docker VM. Select Ubuntu. T2 micro is enough for me. And select a existing key. 10th August. One key is there here. And the network settings. Okay, I am opening all the ports. Why we open all these ports will be knowing later. Add security group. Okay, click on launch instance. Now just connect to this virtual machine. Go to downloads because my key file is there in downloads folder. Here installing Docker is very much easy because there are some ready-made shell scripts are there. Okay, Docker get script. One script is there here. Get script. It is not opening here. Okay, we will do one thing. Docker installation on Ubuntu. I will go to last. There is a shell script here. Just copy the script, paste it over here. Okay, here a script was downloaded. Just run that script. That is it. That's it. Your old Docker is installed. Otherwise, you have to follow this documentation. Each and every step you have to copy paste from here. Rather than executing each and every command, it is better to execute one small shell script so that your Docker will be installed. Now your Docker is installed. Next thing is to execute Docker commands. Every time you need to say sudo because Ubuntu is not an authorized user. So to avoid sudo every time, we have to add this Ubuntu user in the Docker group. How to do that? Sudo user mod -ag Ubuntu Docker. Sorry, yours have to give Docker Ubuntu. Done. Okay. Exit out of this system and come again, connect again, and now execute Docker info. Okay, it is showing something means your Docker installation is successful. Okay, like kernel version, operating system, architecture, CPUs, total memory, IP address, Docker root directory, experiment. So everything is displaying perfectly means your installation of Docker is successful. Okay, this is a server and this is a Docker client. Now my machine is ready where I installed Docker. Now just download one image Docker BusyBox. So to download an image, the command is what? Okay, Docker pull BusyBox. By default, it is going to bring all images from hub.docker.com. That is a default image store. Okay, and if you want to see the images in the local machine, there is a command called Docker image ls. Are you seeing image in the image list? It has displayed me the repository. Okay, BusyBox tag name is latest, and this is a random image ID that is given by Docker. So it was created this one. Guys, I have said you right. 4.26 means how much small it is. It is
Yeah,
really like
minimum,
miracle.
minimum one
And if you
only.
want to create, yes,
That is minimum one, right?
yes.
In Docker.
Now my image is available here. So when my image is available from the image, I can create a container. To create a container, there is a command Docker container run hyphen name C1 IT. What all these I will explain. Okay. Docker container run hyphen name. C1 is a container name. IT means interactive mode. Okay. And so what is the image name? Image name is BusyBox. Now see, we are inside the container. A container is created and we are inside the container. And if you say ls, it is completely separate file system of your container. Okay. I told you right, every container will also have its own process tree, its own file system. Okay. A bin, dev. So this is the file system of your container. Total it is having 2668 directories, 20,396 files. Or if you want to come out from container temporarily, say Control PQ. And if you want to see the list of containers that are running, Docker container ls. Are you seeing one container was created here? And I will create one more container. This container name will be C2 now. From one image, you can create as many containers as you want. Control PQ for temporarily coming out from the container. And if you execute Docker container ls, see it is showing that two containers are created. One is C1, other one is C2. These are running in the background. And if you want to go into the container, if you want to go into the running container, you can say Docker attach C1. Are you seeing presently we are in C1 and you can come out from this and you can again go to Docker container, Docker attach C2. You are inside C2. Okay. So what is the script we have downloaded here? this is a script, right? Docker installation. Second step, execute the above shell script to install Docker. What is that shell script? sh get docker.sh. And once your Docker is installed, what command I executed? Sudo usermod -ag. Okay. Docker Ubuntu or Ubuntu Docker? Which one I executed? Docker Ubuntu, right? So after the what did I say? Exit. I connected again. Reconnect. And after reconnecting, check whether Docker is perfectly working or not by executing Docker info. So as a seventh command, what did I execute? Docker full busybox. Okay, once image is downloaded, from the image, if you want to create a container, Docker container run hyphen name c1 it busybox. And here to see all the images in the local machine. What command I executed? Docker image ls. To come out from container temporarily without stopping it. What command did I execute? Control PQ. Again, if you want to display all the running containers, Docker container ls. Here, if you want to display all running and stopped containers, Docker container ls -a. Okay, it shows all running and stopped containers. So here, first one, it shows only running containers. To connect to a container that is running. What is the command I executed? Docker attach c1 or c2. To remove a container, Docker rm container name. Let us try this. Docker container c1 container rm c1. It will not be deleted. Just look at the message. You cannot remove a running container. Okay, because it is running. So you have to stop it first. Docker stop c1.
Shiva, what does pull busybox script do?
What is that?
Yeah, the number 7 script which you wrote, pull busybox in Visual Studio.
Busybox is it? It is one kind of Linux, like Ubuntu, RHEL, CentOS. How flavors are there? BusyBox is one kind of Linux. BusyBox, Ubuntu, RHEL, CentOS, and many flavors are there. That is one of the flavors of Linux.
So what does the pull command do?
Full form of
Yeah, pull. BusyBox pull.
pull means you are downloading. Pulling
Okay,
means you are downloading image from your hub.docker.com.
okay,
Okay,
thank you.
so once it is downloaded, so from that you can create a container. So
Yes.
first of all, to create a container, image must be there, right?
Yes, yes. Understood.
Now C1 is stopped here. Now if we execute a Docker container ls, C1 will not be shown because C1 is stopped. So if you want to see all containers stopped and running, we have to use -a. -a means all. Or are you seeing C1 is exited about a minute ago? And if you want to remove all containers or running container, you have to use -f C2. C2 is not stopped, right? C2 is running. Okay, you have to use -f to remove a running container also. To remove a running Docker container rm -f C2. And see, as per the diagram, just now we have discussed, when the requested image is not there, when a requested image is not there in the local machine, okay, so it is go and fetch from hub.docker.com or AWS ECR or Azure ACR. Now just I am executing a different command here. Docker container run -hyphen name. I am giving like C3 IT MySQL. Just have a look here. Not MySQL. I will use Ubuntu. MySQL. Ubuntu. MySQL we will discuss later. Just have a look here. Look at the message. Unable to find image locally. Ubuntu latest. So it is downloading image from hub.docker.com. After that, a new image was downloaded and you can see the image. Say Control PQ by executing a command called docker image ls. Totally we have two images. One Ubuntu that is recently downloaded and a BusyBox we have downloaded before earlier. And what is the size of Ubuntu? Just have a look, guys. 77.8 MB. Okay. So this is how you can play with containers. Tomorrow is also a very interesting class. Okay. We can play with containers, like how you can access container from outside, from internet. Okay. Direct accessing of a container from internet is not possible because container, okay, is a completely isolated area with within virtual machine that is created, and such container cannot be accessed from outside. How you can access such container? Suppose a container is running some application which must be accessed from internet. How to do that? That is very interesting discussion. Okay, that we are going to see in the next class. So by tomorrow, you create one account in hub.docker.com and
Okay.
watch this recording and install Docker and execute all these 13 commands. Just now you have written 13 commands, right? Just go and watch this 13 or 14 commands.
Yeah, okay, Shiva.
Okay, guys,
Okay.
I'm stopping the session. How it is like? Is it interesting or it is boring?
It is interesting.
Okay.
So, what is that hypervisor, Shiva?
Hypervisor, that is internally used. We don't use hypervisor.
Okay.
Internally, the cloud providers will be using hypervisor. In Windows
Okay.
10 also one hypervisor software is there.
Uh-huh.
Hyper-V. Using this Hyper-V, we can create virtual machines in our local laptop.
Okay.
Okay, guys,
Okay.
I'm stopping. Tomorrow we
Yeah.
meet again at the same time with same link.